Thank you, Mark. I'll see if I can get us back towards being on time. I'm Daniel Tregeagle from NC State. Introduced myself earlier, a PI and team leader for the economics team. Talk to you today a little bit about the 3 objectives we're working on, the progress we've made towards them, and I think most important, well, a brief summary of the 2 objectives that are more or less complete, and then finally talk about what we need to do from here, in particular coordinating with the other teams to estimate costs and returns to some of these systems that especially teams 1 and 2 have been producing. All right, so just briefly introducing the team. It's 3 of us now. This is a photo UA and I took last year when we were interviewing strawberry nursery growers in Northern California. I think that's Mount Shasta in the background. And then Ezgi Ersoy joined the team earlier this semester. She's a first-year econ PhD student. Previously, as Mark mentioned, the team was a lot bigger. We had 2 other PIs. My grad student graduated, but the 2 PIs left the project first half of last year. So we've been recalibrating, and I think we have a kind of clear pathway to finish off what we need to do. The objectives that we're working on, first objective is essentially to produce a cost and return analysis for indoor cultivated, propagated strawberry plants, and compare that to the existing outdoor systems. The second 2 objectives were much more in the other PI's wheelhouse, supply chain mapping, and then doing supply chain scenario analysis. We have something like that, but they were planning something a lot more spatial about where things were being specifically shipped between, and how the timing of those shipments affected things. So these 2, I've sort of moved some existing work to kind of fall under these categories, much more of a sort of multi-stage, just general market analysis, which is much more my wheelhouse, and also a sort of overview paper documenting the strawberry nursery industry in California and comparing it to Europe, identifying some of the challenges and opportunities it faces, sort of very much a grounding framework that I hope some of these other researchers and certainly our subsequent work can build on top of. The cost and return analysis is ongoing. We've been talking to some of the teams 1 and 2 about collecting data, and was working with Ibrahim extensively earlier this year on a pilot, thinking about how to collect data and turn it into useful outputs. So I'll talk briefly about the 2 papers that are under review. First one is an overview of the California nursery, sort of being generally the foundation of plant production. And big thank you to Gerald for the paper that you published in 2024, overviewing the strawberry industry as a whole, and then a small section on the nursery part of that. That was really helpful for us. Pointing out that California is sort of the home of the starting point of strawberry production and the nursery process. Point of this paper is to document the challenges, opportunities, the reason this project exists. There was very little published literature that we could find outlining the sort of industry structure, the economics of it, the sort of strategic challenges that it faces. Mark's and the team's narrative for the SCRI grant was the most comprehensive document we could find, and that's not really published and citable. So where this paper is the paper that we would have needed at the start of the project to sort of help justify the analysis, the whole project, and hopefully if there's an SCRI PIP-CAP 2, it'll be helpful for that. So talking about and identifying some of the existing challenges, obviously the plant diseases, you know all about that. The reliance on methyl bromide as a soil cleanser in outdoor production, if that regulation is, the regulatory environment changes, that would not be available, and what would be done instead. Labor issue, we heard a lot about that from the growers this morning, and then the climate risks, the need for chilling hours and certain timing changing over time. So anyway, this industry using Gerald's number of about 1.5 billion plants being grown and using cost and return studies from Davis to get a number on that, something in the order of like $200-ish million a year, just the plants. The fruit are worth a lot more. And these are the topics that we discuss in the paper. So opportunities of like indoor production compared to outdoor production, the ability to control diseases, or I think I got a more nuanced understanding this morning. There are disease challenges indoors as well as outdoors, but climate resilience, production stability, and timing, output prediction, predictability, supply chain benefits about where these things are located, and the ability to perhaps adapt to changes in regulations regarding pesticides and fumigants. Obviously, the challenges that are faced, Mark.
Yeah, sorry, I wasn't really trying, but that's based on the interviews that you did, I believe, from
24, started 24, yeah. Plus what everyone learned from field trips in 2022, and the small amount of literature that we could scrape on the topic. Okay. Yes, good point, Mark. Part of this is based on extensive, long form interviews with 3 companies out in California, started last year. That was why we were up near Mount Shasta. Yeah, so the challenges, obviously high capital costs. Building greenhouses is very expensive. The scale of production, growing 1.5 billion, if the industry were to switch indoors, growing 1.5 billion plants requires a lot of space still. I was doing some back of the envelope calculations just now. That would probably require 3,000 to 4,000 acres of greenhouse and billions of dollars of capital investment. That's a major barrier. And the workforce barriers, we're hearing that the labor costs, the labor requirements may increase this morning, and the type of labor required may change because there's a different set of challenges for indoor production compared to outdoor production. What will the transition be like? And then also the knowledge gaps, optimizing these systems. That's a major component of this project. So that's the outline of that paper. It's currently R&R at the International Journal of Fruit Science, so hopefully that's be published sooner or later. The second one is a market impact model of if the indoor production scaled up, became relatively cheaper compared to outdoor production, what are the likely impacts on outdoor producers, indoor producers, fruit producers, and the consumer at the end of the day. This is kind of the overall structure of the model. We have 2 types of firms producing plants, which are sold to fruit producers. They produce fruit, goes to retailers, sell to consumers. We saw a version of this last year. It's essentially the same. And point of this model is you have supply and demand in each of these market stages. You impose a shock on the indoor sector based on research that you've produced, for example, and then see how that flows through all the different components of the system. So we represent an improvement of CEA technology as being a reduction in the marginal cost of production for indoor production. So you can represent quality changes as the marginal costs in the model like this, and so that's how we introduce the shock. That is old, yeah. So under each kind of scenario, we draw parameters randomly from a set of plausible parameters based on published data where possible, based on our conversations where we don't have published data. We simulate that many, many times. You get a range of outputs, and this is kind of an example for one of the scenarios of the range of outputs and scale and magnitude and sign of the impacts of that improvement in indoor technology. So this is incorrect. This should be the 50% market penetration. So this is not the scenario I wanted to show you, but the numbers are bigger, but the signs are the same. The point being that for conventional outdoor producers, improving CEA technology is likely to reduce their profitability. For indoor production, improvement of their technology is likely to increase their profitability. This is a distribution of all the different scenarios we ran on sort of somewhat logarithmic graphs, technically inverse hyperbolic sine. Consumer surplus is always improved if you can make strawberries cheaper. And total surplus is very much driven by consumer surplus. I wanted to show you the 10% market penetration scenario, which is much more relevant. It's the same as these, everything's just scaled down. So the conventional plant losses are more in the order of like 0.5 The improvement in producer surplus for indoor would be more like 1 to 2 million. So relatively small absolute numbers, the signs are the same. So the remaining item is to work on the cost and returns. We kind of have 3 objectives here to try and quantify the experimental costs that you've been doing in your labs. Use that to create a model to compare the profitability of outdoor versus indoor systems, appropriately counting for all the capital costs involved, and then get a sense of what the maximum price that fruit growers might be willing to pay to buy indoor grown plants, assuming there are quality differences between the existing outdoor plants. The aim here is essentially to produce a production function where we have a production sequence. We know the inputs and the timing required to take fertilizer and meristem culture and substrate, and turn that into marketable product of cut strawberry nursery plug plants, I suppose, who can be sold to fruit growers. We've been working, as I said, with Mark and Ibrahim earlier this year to get a handle on their system. This is sort of a representative map of that. So it's beginning with preparing, obtaining the tissue culture and rooting, and then a process of tip cutting and monthly management. The aim here is to have for all the groups combine them together to have a sequence of steps necessary to produce the plants, know what the inputs are for those steps, either from their data or we can collect it separately, figure out the prices of each of those inputs, and thus say what's the kind of marginal cost of production of plants in a process like this. Obviously, scaling that up, you'd expect the prices to drop substantially, and there is some information about the differences between research costs and commercial production for things like this. Hopefully we can learn a little bit more today and tomorrow. That's the ongoing work. Need to have more conversations with the other PIs about collecting this data, synthesizing it, and hopefully we'll have more to share with you later this year or early next year. Thank you. And thank you to the PIP-CAP project for funding this work.
Very good questions. So what's the current price differential between the two right now? The running, the 2025 cost price differential? Indoor plants versus, I don't know, my berries.
Yeah, no, that I'm not sure. That's not the model. We didn't have that data for the model. It was just a range of plausible price differences that might exist. This is a what if scenario.
Yeah, what's the difference for us?
For the cost for the grower, so I don't know what the berry goes for, like probably like what, below 20 cents and 18 cents or 50 cents in the berry.
That's what I'm asking you. I'm
Right.
curious what the difference is. I don't buy these.
It's probably like for a block plant, it's probably double at least to berry, right? And then for a tray plant, they usually go for $1.90, like a big, like
Yeah.
that's not the big, so
Right.
it's quite a lot, right?
Yeah, the Davis cost studies have like 15 cents per plant, but that's I think for outdoor grown plants.
Yeah, that's what they are, so the black plant goes from 30.
Yeah.
So
That is, yeah, well, normally when I buy from the greenhouse, it's 34 cents.
That's the qualities on it.
But I don't know about control. Control is
Yeah,
probably gonna be
so
higher.
black plant outdoor propagator 30. If you completely greenhouse, they probably go around closer to 40, like 57, right? And then tray plant are more expensive.
We were using a range from equal to triple the price, relative price. Yeah. Okay. Oh, thank you.
All right, my turn. Hillary, did that answer your question, or do you have, do you want more details?
No, that's good.
Okay. Yeah, so bare roots are by far the cheapest still to ship and to produce, right? Like on the scale that California is doing them. That's this is a plug brand, and that product here, if you would buy that here, would be around double the price of what bare root would cost without shipping. So that's one of the reasons why we grow a lot of bare root, is because of shipping. They come from California for the most part. That's why we grow
What
it.
is the incentive right now for the growers who are buying these color plants?
There's
Other than I mean, they're indoor growers, so a plug is easier in that environment, or?
no, so the incentive for growers is, so this is a niche product. I mean, you know that's a niche product, right? The incentive for growers is, for the most part, first, it's easier available here than a bare root plant, right? So they can, because a lot of the California nurseries tend not to ship here, or often they, there's like a big truck, and then we have like the small growers, so they have to like join
The
up.
supply.
And here they can just drive to the supplier and buy it, right? So that's easier for them as well to get it here, right? That's why it's a product. And then the pitch that the indoor nurseries do that are not in this like loop that Bird is in, right? Like where they have like their greenhouse growers in New York, and they have preparatory materials. So the pitch that the indoor growers Canada or North Farms that you're going to talk to tomorrow would do is their material is superior, so they don't have any disease issues, right? There's no NEOP in it. That's a pitch for them, right? And that's why people often buy or want to buy their material, but it's more expensive. Like a plug-in from an indoor grower, North, I think you're gonna pay probably close to 40 for that. We asked him tomorrow what he really charges for those, but they're typically more expensive. But we had growers last year, because of all the NEOP scare, right? They went to the indoor indoor propagators and bought their material. Does that make sense?
It doesn't to me, because
Yeah.
it's such a higher risk environment for both Pestalozzi and for, foliar, for diseases and for insect transmitted diseases.
Yeah, but they were more.
And I had to write letters to like big customers, like
Right.
Costco's and Walmart's.
Right.
Assuring that the plants were coming from California, from my East Coast.
Right, yeah, so we had both things going on here. We had like trying people to get material from the West Coast because.
Yeah.
They
So
want-
you're given access issue, that makes a lot of sense.
Yes.
You have an access issue to
That's
plants
correct.
that are grown in an outdoor ideal environment under drier conditions.
That's correct.
Right.
That's correct. That's exactly what it is. So we had a lot of people pitching to the West Coast, but not everybody got their plants there, right? So then there's this niche in the market that.
And the increase in, I don't wanna divert this one, but the
No,
increase
you're
in Idaho nurseries is not trickling down to the southeast and the west, because that is for the southeast.
It is. So Idaho picked up a lot, but they weren't able to pick up everything, right? So there's like this niche that's there where some growers can't go to Idaho because they're sold out or whatever, for whatever reason, or they're like somewhere in the boonies and they don't ship there, right? So that's where those nurseries get their pitch, right? So that's one of the reasons, right? And then their pitch was, because we're growing indoors, we don't have that much NEOP because we like in a drier environment, and that's why our plants might be cleaner, right? That was one of the pitches last year, at least, right? So.
You're also out of soil, right? You're in soil, but you're in a substrate, supposed to be stale substrate. That's one of the pitches. Yeah, you have a foliar disease, you can maybe be able to spread it easier in that kind of environment in a better field, but you don't have access to the soil.
Yeah, but I think the real risk here is Pestalozzi. That's
Right.
spoken risk.
Yes, it is. The real risk, yeah, at the moment, it's Pestalozzi, and then there's.
Cause their temptation, right, they're not shaking tissue culture plants every year. They're not starting with Houston mothers.
No, I don't think so.
They can't afford to.
No, they can't. They usually get white tags from California, right? That's usually their starting material. Yeah, so, yeah. The California nurseries, without California, nothing would work here, right? That's like literally what it is. Like the nurseries get mostly California plant material as their stock material, some substitute with tissue culture. But the customer base is so much smaller than what California orders and has, that to me, California is always like this main driving force in the US strawberry industry, right? It's like without this, like this engine that rolls all the time, and without it, it wouldn't work, right?
But it's important to clarify because we started this project before new people.
Yeah, we started this before.
So why do we do that?
Because we had things like anthracnose and other diseases that showed up mostly in like locations like Florida and the southeast and sometimes in Southern California, right? Where we have sometimes some issues, right? And that's,
And those risks is still
Right.
exists. It's just now NLP is.
yeah, but NEOP is right now the big issue, right? Yeah. All right. Any more questions? You can ask me any question anytime, Frederick, I'm happy. All right, so this is gonna be quick.